Hello everyone, welcome back. So in this video we are going to see the differences between open loop control system and closed loop control system. Okay, so differences between the two types of control systems. So if you are first time to my channel, please consider subscribing. So I have discussed what is open loop control system and what is closed loop control system in the previous video. So if you have not seen that video, please pause here, go to that video, see that video, understand what is open loop and closed loop control system, and then come back here to understand the differences between open loop and closed loop control system. So the first difference is all the open loop control systems are manually operated systems. So all of those manually operated systems are open loop control systems. Okay, so there is no mechanism here in order to feed back the output back to input to not generate the error. So, and in contrary, all closed loop control systems are automatically operated systems. Okay, so all the automatically operated systems are closed loop control systems. Okay, so example, microwave oven, it can adjust all the automatic microwave ovens are there which adjust the temperature accordingly. Automatic AC is there which adjust the temperature based on the temperature of the room that is surrounding. Okay, so all the automatically operated systems are closed loop control systems and the manually operated systems are open loop control system. So second difference is open loop control system does not have any feedback. So no feedback mechanism is present in open loop control system, but closed loop control system the feedback is present. So in all the closed loop control systems, feedback is going to be present. Okay, so this is the basic difference or important difference between open loop and closed loop control system. So the next is third is the transfer functions of open loop and closed loop control system. So what is transfer function? So I'll explain you this about this transfer function in the next video clearly, but as of now, to write the difference, that means to write the open loop and closed loop transfer functions, I'll explain you the basics here. So generally the reference input, which I have told you in the previous input, so reference input is always represented by R of t. Throughout the subject which we are going to discuss from this video to the end, will represent the input with R of t only. Okay, so R of t is input, C of t is your output, and E of t is the error signal. Okay, so E of t is the error signal. So its corresponding Laplace transform will be R of s. The Laplace transform of C of t, that is output, is C of s, and the error Laplace transform is E of s. So the ratio of output Laplace transform by input Laplace transform is called as transfer function. Okay, ratio of output by input Laplace transform is called as transfer function. So I'll explain you this in the next video very clearly, and how to find the transfer function also we're going to solve some examples. Okay, so don't worry about this, we'll discuss that clearly in the next video. So we know that open loop control system has only controller, that is G of s, and you are going to get the output, so that is C of s here and R of s here in the case of open loop control system. So the corresponding transfer function of an open loop control system is called as open loop transfer function, OLTF, we'll call that as in short OLTF, open loop transfer function. So we know that the output is always equal to the product of input and system. So this G of s is the system here. Okay, So G of S is system, so OLTF. So C of S is always equal to R of S into G of S, because we know that the output is always equal to the convolution of input and system. So convolution in time domain, from the property of Laplace transform, convolution in time domain is equal to multiplication of their transforms in Laplace domain. Okay, so by this we'll get open loop transfer function is equal to C of S by R of S. So send this R of S this side to the left hand side, so we'll get only G of S. So this is your open loop transfer function. Okay, but in the case of closed loop control system, there is feedback mechanism. So there is feedback mechanism. So this feedback mechanism is again of two types. One is positive feedback and the other is negative feedback. Okay, so we'll have different characteristics for positive and negative feedback. Negative feedback is used in amplifiers and positive feedback is used in oscillators. So these are the differences between negative and positive feedback. So that is not required for our subject now. Okay, so we'll discuss this when we discuss analog circuits concepts. Okay, so positive and negative feedback is there. So for positive feedback, so when there is positive feedback, so the feedback is going to be positive here. So that is important. Always R of S is positive, but the feedback is also positive. Then that type of system is called as positive feedback system. So this is the controller, so G of S, and there will be some feedback mechanism. So we'll represent that feedback as H of S. Okay, so throughout the subject we are going to represent using H of S only. So this is your C of S. Okay, so C of S by R of S is given by G of S by 1 minus G of S into H of S. This is for positive feedback. Okay, so this is for positive feedback, and this is called as closed loop transfer function, because this is for closed loop control system. So this is called as closed loop transfer function. Okay, so the important point here to be noted is the ratio, or sorry, the angle between, or the phase shift between G of S and H of S. That is the controlling action, the controller and the feedback network is G of S and H of S is going to be 0 degrees or 360 degrees. Okay, so 0 degrees or 360 degrees in the case of positive feedback. Similarly, if you draw the block diagram for a negative feedback system, so the only difference here is the feedback is going to be negative here. The feedback is going to be negative. So this is G of S, and same this the feedback network is present. Sim H of S will represent it with H of S. So this is your R of S, the input, and this is your controlled output C of S. So the ratio C of S by R of S is G of S by 1 plus G of S into H of S. Okay, so G of S by 1 plus G of S into H of S. So this is the closed loop transfer function for negative feedback system. Okay, so for negative feedback, the phase shift between G of S and H of S is 180 degrees. So the phase shift between input and the phase shift between the system G of S and the feedback network H of S is 180 degrees. Okay, so the disadvantage here for negative, generally we'll use, in most of the cases we'll use negative feedback only, because positive feedback, so positive feedback there are many disadvantages. So we'll discuss that in a different video. Okay, so negative feedback, generally we'll use negative feedback, and the only disadvantage of negative feedback is when compared to open loop transfer function. So the gain here is G of S, that is the ratio of input by output, and the gain here is G of S by 1 plus G of S into H of S. So the main difference, the main disadvantage is, so gain decreases here. Okay, in negative feedback, gain decreases by a factor of 1 plus g of s into h of s. So this is very important point. So in what is the disadvantage of negative feedback is the gain decreases by a factor of 1 plus g of s into h of s. Okay, so this is the basic difference between open loop and closed loop control system. So the next difference is fourth one. In open loop control system, stability is less. So in open loop control system, stability is going to be less. It is less stable. And closed loop control system, the stability is going to be more. That means the output stability. We are talking about the stability of the output. So if there is no proper controlling mechanism, so stability is going to be less. If there is any changes in the components of the system which we are going to design, there will always be changes in the output. But in the case of closed loop control system, even if the component, even if any component in the system changes, then it is fed back to the input. So proper controlling action is there through the feedback network. So stability is more. Okay, we can't say that it is completely stable, but when compared to open loop control system, the stability is going to be more. Okay, since stability is going to be very less, so open loop control system is less accurate. Okay, so since stability is less, so open loop control system is going to be less accurate, and closed loop control system is going to be more accurate when compared to closed open loop control system. Closed loop system is going to be more accurate. And the next is, say, in open loop control system, sensitivity is more. Sensitivity is more. And in closed loop control system, sensitivity is less. Sensitivity is going to be less. So sensitivity is less. So is it an advantage or disadvantage? So it is an advantage. What is sensitivity actually? So sensitivity is the effect of system output, effect of the system output due to external noise. Okay, so the change in the system output, we'll call that as change here, effect or change in the system output due to external noise or any disturbances. Okay, so any disturbances, due to any disturbances or external noise, if the output changes rapidly, then we will call that as sensitivity is going to be more. Since there is no proper controlling mechanism here, in the case of open loop control system, sensitivity is going to be more. That means if there is any noise present in the system, then the output changes rapidly, which deviates from our desired output. Okay, so there is always the chances in open loop control system, if there is any noise, then the output deviates from the desired output. But since there is proper controlling mechanism through feedback network, in the case of closed loop control system, sensitivity is going to be less. So for any good system, the sensitivity must be low. Sensitivity must be low. That means the response with respect to external noise must be as low as possible. So it should not, the output should not affect to the external noises or disturbances. So if it is not affecting, means sensitivity is going to be less. So for any good system, sensitivity must be low. Okay, so this is one of the difference between open loop and closed loop control system. So the next difference is, in open loop control system, bandwidth is more. Bandwidth is more. in closed loop control system bandwidth is open loop control system bandwidth is less. In open loop control system bandwidth is going to be more. So if why bandwidth is more, we know that for any system or for any circuit the product of gain bandwidth must be constant. Gain and bandwidth must be constant. If one decreases, the other should increase. So as we have seen in closed loop control system, gain decreases by a factor of 1 plus g of s into h of s, because we have got C of s by R of s is equal to g of s by 1 plus g of s into h of s. Okay, so gain decreases by this factor 1 plus g of s into h of s. So gain is going to be decreased, so that bandwidth must increase. That means bandwidth will be increased by the same factor, by this factor only. Bandwidth increases by a factor of, so after feedback, so bandwidth with feedback is bandwidth into, that is without feedback, 1 plus g of s into h of s. Okay, so this bandwidth must increase in order to make this product constant. Okay, so this is how bandwidth is going to be more. So what is the advantage when bandwidth is more? So we know that for any circuit bandwidth is inversely proportional to rise time. So generally we'll take it as TR is equal to 0.35 by 0.35 divided by bandwidth. Okay, so normally bandwidth is inversely proportional to rise time. So in closed loop control system, when bandwidth is more, rise time is going to be less, and we know that rise time is inversely proportional to system response, that is fast in system response. So since TR is going to be very less in closed loop control system, so there will be a quick response in closed loop control system. So this is why closed loop control system gives quick response when compared to open loop control system. Okay, so this is the mechanism happening. So I'll repeat it once again. So since gain is decreasing by a factor of 1 plus g of s into h of s, bandwidth is going to be increased, because gain bandwidth product must be a constant by the same factor. So bandwidth is more in the case of closed loop control system when compared to open loop control system. So here gain is more. In the case of open loop control system, gain is more, so bandwidth is going to be less in order to make the output constant, in order to make the product constant. So similarly, when bandwidth is more, then rise time is going to be less. Rise time is the time required for the system to rise to the 90% of the output. Okay, so I'll discuss this when time response concept comes in control systems. Okay, so bandwidth is inversely proportional to rise time. So that means the time required to get the output. Rise time is the time required to get the output. Okay, so if bandwidth increases, then rise time decreases. So when rise time decreases, we can get the output in a less amount of time. That is, there is fastness in the response. Okay, there is fast response available at the output of closed loop control system. So that is why closed loop control system gives quick response when compared to open loop control system. Okay, so these are the basic differences between open loop and closed loop control system, right? So in the next class we are going to learn about transfer function. Okay.